Welcome to the Cosmic Pie Podcast, Year 4.
Year 4, season 4.
I knew I'd get you on this one.
Well,
Season 4, episode
5.
5. You see? Not 4.
Give me 5.
That would be 10.
Okay.
Wait till we get to 10.
There we go.
We are broadcasting live from the campus of the University of North Dakota here in Grand Forks, North Dakota. We do have a chat feature that is running, so if you have any comments or questions or answers.
We'll try to get to them.
Or maybe you have like your own Mein Kampf you want to tell us about.
No, let's not do that.
Okay.
Let's not go there.
Just send us some very interesting questions and we'll do all we can to answer them. And if we can't answer, we'll look up the answers later on and get back to you on the next podcast. How's that?
We'll do that. Yeah.
Now, just to remind you that besides broadcasting live here on YouTube, that we also upload our episodes on Spotify. So if you'd rather watch on Spotify, and there are some advantages to that. They got a nice, beautiful outline. You know, the way they do the platform itself is really pretty how they set things up. You haven't checked us out on Spotify,
I
Robert?
haven't checked us out on Spotify. I don't use Spotify a lot. So.
Anyways, we are there for sure. Now, Robert, what is this time for what? Robert, I always make you do this.
Oh, okay. You always make me do our disclaimer. Yeah. So the opinions and all that expressed herein are those of myself and Wayne. They are not the opinions of the University of North Dakota, the Department of Physics and Astrophysics. Just us, folks. Blame us.
Blame us.
Blame us.
Big day today. Well, really yesterday, but it kind of bleeds into today.
Yeah.
Question for you, Robert.
Okay.
If you were going on a long vacation
Okay.
and there was gasoline laying underneath your car, would you go or would you kind of take extra time and maybe get it to a garage and get it checked out?
Was I expecting gasoline?
No, you were not.
Then I would go get it checked out.
You would get it checked out. And that's
I would
exact.
Probably, in fact, get it towed to the garage because I ain't cranking it up.
And no smoking any darts around there. You know?
Right.
So that's where we're going to open up our discussion today is the big news that's been going on. This is a kind of a still from NASA from yesterday where the Artemis 2 SLS rocket, the Space Launch System rocket, was undergoing what they call a wet dress rehearsal. This is different from a dry dress rehearsal. And the difference is, in this case, you're actually fueling up the rocket full of fuel and oxidizer to get it ready for launch. All the things essentially you would do for launch, except you don't take real astronauts and putting at the top in the Orion capsule.
And you don't strike the match.
And you don't light it, obviously. So they were supposed to count down all the way to essentially T = 0 without actually lighting the match, as Robert said. And there was a practice test. Of course, if there are any bugs or any problems you want to work out, do all the troubleshooting before you get to the point where you actually have astronauts at the top ready to go, in this case, to the moon. How exciting is that?
It's pretty cool.
And you want to make sure that the rocket at least is going to function as well as you think it should beforehand. So work the problem now, and you don't have to worry about it later when things become even more challenging in some sense.
Right.
So what happened in this case, and it's not unusual, this has occurred in the past. In fact, for those of you who remember a few years ago when they were getting ready to launch Artemis 1, which was the unmanned version of this rocket to test the system, it was delayed for quite a while, and there were a lot of problems in the tanking of the rocket itself. So what you have to do is you have to put liquid hydrogen. Now, what temperature is liquid hydrogen? Is like minus 400 and some Fahrenheit.
Yeah, it's like 3 Kelvin or something.
Yeah, it's extremely cold. I mean, hydrogen is normally in a gas phase here on the Earth, and you want to compress that down and cool it, and so you can get it into the liquid form. And it's extremely flammable,
right,
as most of us know, and it makes for a good rocket fuel. And what you want to add to it, though, is a source of oxygen. In this case, it's liquid oxygen, and that's extremely cold as well.
Right.
So you're dealing with what we call cryogenic fluids. So these are fluids under extremely cold conditions. Well, if you take a pipe, and we're familiar with this a little bit in North Dakota.
Just a little bit.
You take a water pipe, right, and you put some nice fancy fittings on it in the summertime. Maybe you solder some ends to it or whatever. And then you take that whole contraption and throw it into the coldest night you can get in North Dakota, usually in January. And that thing is going to contract, that metal.
Right.
And it's not unexpected that you could get leaks. You could get cracks that form in your apparatus or whatever, because you have to compensate for the contracting of and expansion of the metal when it gets warm. So when you're pumping fluid through essentially a pipe system, and that pipe system is at ambient temperature, and I'll give it to you, Florida right now is not at the highest temperature that can happen. They're
But
down
it's still
around
a far
high.
cry from locks.
Their highs, in the 40s, maybe low 50s or something right now. They go through this cold spell, and you can see it on the news, of course, all about it. But yeah, even if you're at 40 degrees Fahrenheit and you start pumping in liquid hydrogen or liquid oxygen through the piping system, things contract rapidly.
Yes.
And you can control that by just piping in a little bit of it to kind of ease the sudden contraction that would take place.
Right.
To try to get the system cooled down,
Was just telling some students this morning or early this afternoon, that in physics we often have a saying, interesting things happen at the interface. And temporal can be an interface. If something happens rapidly, you get an interface. And so, yes, you pump it slowly to get things to cool down and contract. Then you gush.
Yes, and then the other thing, you always have usually O-rings or rubber gaskets and stuff between parts, and the stuff is not a straight line. There are fittings, there are structure that you have to fit to it, and so it makes it much more complicated. And so it's not surprising that you're going to get hydrogen that leaks through some cracks, and the hydrogen, being a single atom, is a little easier to leak through things.
I was about to say, the interesting thing is that hydrogen leaches or dissolves into everything, because it is such a small molecule, such a small atom. Conversely, liquid oxygen is a horrifically powerful. Oxygen is a bad oxidizer to begin with. It oxidizes with just about everything. But when you cool it down to cryo temperatures, liquid oxygen is many times more oxidizing. And so it corrodes everything. So yeah, it's not, what's surprising is that we can make materials that can contain either of these substances for any length of time.
So the design, it's very difficult, even from an engineering point of view, to get the system to work. And there's even tolerances set up, like during refueling or fueling up the tank for the first time, and then that stuff evaporates, even when you got the tank full. Because of the evaporation, you got to keep topping off the tank until the moment of launch.
Right.
All of that type of engineering needs to be done. There's always leaks that occur. They just set up a certain criteria. Okay, if it leaks more than this certain rate, then we shut the thing down. We're not launching. Because and one of the reasons is, of course, if you want hydrogen leaking around your fittings of your pipes, and if there's a large amount of it, it's like trying to tolerate natural gas leaks.
Right.
If you walk into your furnace room and you get a faint whiff of natural gas,
it's time to call
and it's very, very faint, barely detectable, it may or may not be time to call somebody, right? But if you come in and there's a strong odor of natural gas, number one, leave your house immediately and then call somebody.
Right.
Because you never know when the thing blows up, and we've seen lots of examples of that.
I ain't gonna
occur several times a year on the news.
I smell that mercaptan smell, which is what the natural gas smell is. It's chemical they add to it.
Right.
Called mercaptan. I even get a hint of that smell. I'm like, time to call somebody.
Yeah. So that can be extremely dangerous. But anyway, so there are limits, and if you violate those limits, obviously things will shut down.
Right.
And so what happened yesterday is they started filling up the hydrogen in the oxygen tank and the external tank, if you want to call it that. It's kind of the core stage of the rocket itself. And there were leaks at different places at the fittings and so on. And they did different things to adjust. They slowed down the fill rate, and they sped it back up again. And they did different things that they can do during the actual process to try to get it to the point where you have your core stage filled with the fuel and oxidizer, which they got to, and then they fill up the upper stage. And they got all the way down to about 5 minutes before the simulated launch. So they didn't quite get to meeting their objectives of the test. But in some sense it did work because they discovered all of these issues.
Right.
So whatever problems they had with Artemis 1, it's kind of in the same location where there's fittings coming out of the launch structure, right? There's different parts where pipes have to come through to attach to the rocket itself. And those are weak areas where you potentially can have problems, and certainly there were problems. And so those things need to be taken care of before they can launch. And there's no rush in launching.
Mm-hmm. Yeah.
So they were going to do this test last week, so on Saturday, and they postponed it for Monday of this week.
Okay.
And because of that postponement, the earliest they could launch was Super Bowl Sunday that night.
Ah.
See, so everybody would pause from watching the Super Bowl.
Yeah.
Everything on hold to see the launch to the moon or something. I mean, it'd be kind of a weird thing. But now, because of these leaks, all of the February times that were available to launch, which you see there in the bottom of the slide, are now gone. So the earliest they're going to go is in March.
Okay.
And that may not happen. And there's a few dates in March, 6th to the 9th, and then again on the 11th of March, assuming they don't change those dates. And if we don't make those dates, then it becomes the first week of April. So if you're planning your trip down to Florida, number one, hopefully you didn't buy tickets to go in February. Number two, if you did, hopefully you got cancellation insurance on those tickets, or you go anyways and enjoy the weather. Hopefully it warms up by the time you get there. You don't want to go to Florida looking for a nice warm vacation and it's, maximum temperature is 45 degrees in the daytime. That'd be kind of disappointing.
And we got iguana bombs going on.
Yes, right. If you've never seen it, the cold-blooded iguanas fall out of the trees. And I seen this, they collected over 2,000 of them.
Right.
And counting, right? And they look like they're toy iguanas. When you see them, they're all like in a box or a container, overlapping each other at various angles, just like rubbered iguanas you see in the store. And they're actually alive still. They look like they're all dead.
Right.
It's amazing, what happens to them at the very low temperature. Imagine that happened to us. Like, we wouldn't move, right, when we're living here. We wouldn't move from, probably end of November all the way to sometime late March.
Right?
Anyways, that'd be kind of weird. So hopefully you're able to get down if it goes in March. And, that's in our spring break, Robert.
Oh, yeah, it is.
So that might be more advantageous. Now, if we win the lottery between now and then, we will have the money to go to Florida, you see.
Yes.
And if the launch doesn't happen, I'm sure by March it's going to be warmer than here. So we get to enjoy that. Head to the beach or something, right? If there's no launch.
I'm originally from the New Orleans area, so I can say, it will be much warmer in March than it is here.
So that's the status so far. Like I said, there's no rush to get this thing off. You want to make sure that everything is safe. And even on launch day, who's to say what problems they end up with? And they have to go through the long process of troubleshooting those issues. And it may or may not launch. We know how historically
if it's
rocket...
go or no go, yeah.
I mean, if you go to Florida to see a rocket launch and it actually happens on the time that was planned, and this even included in the past when they were launching space shuttles and so on, count yourself really lucky.
Yep.
Because
it doesn't go off without a hit.
No, most of the times there's probably delayed. I mean, there's been enough launches, starting with the humans space program from Mercury days through Gemini, through Apollo, through Space Shuttle, and now into this, that you could kind of track when were the launches originally scheduled and did they go on time or not. I don't know what that number is, but it's got to be more than 50% did not go on time.
Right.
It's got to be.
I would be surprised if it wasn't.
Yeah. But ultimately, the goal and why this is so important, of course, is to have humans going back to the moon. There are other countries that are interested in doing this, like there were in the 60s.
Right.
I mean, the Soviet Union, of course, was very much interested in putting cosmonauts on the moon before the United States put astronauts on the moon. But they just didn't develop the technology to the point where it was useful to do that, as it's well documented now. And so we're doing the same thing, except really the Soviet Union, which no longer exists. It's Russia, of course, but it's China is the one that's pushing their people to land on the moon somewhere around 2030 or so. And it's 2026. That's only 4 years from now. And
yeah, but they got some pretty good rockets.
They do. So, and I can see them taking a crack at it, just to do it, not to stay there forever at this time, but at least to go there, make a touchdown, soft landing, hopefully, do a little bit of exploration, and then try to get them back to the Earth without any kind of issues. I can see them then trying to do that, and we'll have to wait and see, how this all develops. And the other thing is, of course, it's not a completely open society like the United States.
So we don't know where
So it's hard to keep track of what progress they're doing or any problems that they're having, right? It's harder to get that information. But for the Artemis program, the launch here is to have astronauts to go around the moon and then return to the Earth. So they're not going in orbit around the moon, just what we call a free return trajectory. So you just go in, go around the far side of the moon, and then back out again, and then back to Earth. But the other thing, and they always say, oh, this is, if you think of some of the historical firsts on this mission that's coming up from Artemis 2, this is the furthest away in deep space, they like to say, right, that humans will ever be. And that's because when they go on the far side of the moon, they're not close to the surface of the moon. Back in the Apollo days, when they went around to the far side of the moon, that's when they fired the command service module engine to slow them down, to put them in orbit around the moon. So when they come out to the near side, then they are in low lunar orbit. Right. That's not the case here. You're zipping around the far side of the moon and going away from the moon quite a bit and then coming back. And so because of that, you are technically going to be the furthest away from the Earth that humans has ever been in the history of humankind. Think of it that way, Robert. How profound is that?
Yeah. Something to do. So, sorry, I advanced the slide a little sooner than you wanted.
No, it's okay. So going to the next slide, this is where this enters the story. So it's a good segue here. Artemis 3 is the one in which we're supposed to land on the moon. Yeah. Now, you don't want to land on the moon in an area where we've been before. That would defeat the purpose.
Right.
And those areas are close to the equator of the moon. They're not on the equator, but they're reasonably close. And they're all, of course, on the near side of the moon because of the communication. You want to be in constant communication with Earth, of course, during this time. Right. So so we want to make things a little different this time. So number one, we could have people land on the far side of the moon.
Right.
But that would require that you need to have some kind of a communicating satellite, a relay satellite, in orbit around the moon itself.
Pretty much in counter orbit to the command module or whatever they're going to call it.
So you could have that. In fact, you could have multiple ones for in case of failure. You could have 10 of them orbiting the moon, and so you'd always be in constant communication, even if you are on the far side of the moon, where the moon literally blocks any signal from getting to the Earth directly.
Unless you're around a black hole, light is kind of line of sight, Now, no matter what wavelength.
But the other thing you could do, which is what they're doing here, is you could land near one of the polar regions. So these are one of the unkind of explored areas of the moon. We've taken pictures from lunar orbit, of course. From the Earth, you can't get a good view because the angle of viewing is so shallow, so small, that you can't see what's down inside of the craters. And the other thing is, a lot of these craters are in perpetual darkness. Even sunlight is not able to penetrate down into the bottom of the craters themselves. They're too deep in that sense. And because you're at the pole of the moon, and the moon's, it's like it's within 5 degrees of the Earth-Sun orbital plane, so it's not like the sun is above the poles of the moon at any time. And so there are places in the bottom of these craters that are in these perpetual darkness all of the time. Right. But what's in the bottom of those craters? Is it a one-eyed monster that's green in color and does not breathe, right? So it's able to sustain in the vacuum environment, and it eats lunar rocks for food.
Right. Yeah, I don't think that's what it is.
But what is in the bottom of those craters for sure? Yeah. Well, you don't know until you go look, right?
Right. But there's evidence that it may be ice.
Yeah, and it's
water ice.
Water ice, yeah, and that's the important thing. If it is water ice, that helps a lot because that's a reservoir that we could use to help sustain human activity on the surface of the moon. And anytime you don't have to bring a gallon of water to the surface of the moon.
Nearly 9 pounds.
Yeah, that saves a lot of money, right?
Yeah.
And so, and then also an emergency. You never know what happens on the Earth, and all of a sudden they can't launch for a while. You don't want to run out of water. So in an emergency, of course, there can be a supply of water. And we've had unmanned spacecraft that did radar, probing the bottom of these craters on both the South and the North Pole. It seems like the South Pole is a better area in terms of being in an area that could potentially have water ice. There's one of the things they look for is the escape of hydrogen.
Escape of hydrogen. They look for radar, certain specific wavelengths of radar that are reflective. That shouldn't be if it's just rock, and just various things like that. So they did much the same thing with Messenger around Mercury.
Yeah.
and found some highly reflective zones in the deep craters at the poles of Mercury. Is it water? Strong evidence, but we won't know until we can look directly down into these craters.
Yeah, I mean, one of the missions, which was actually funded by the U.S. military, was the Clementine spacecraft.
Mm-hmm.
That was in orbit around the moon, probing into those bottom of those craters. And there were indications that there was an excess amount of hydrogen that was escaping from those areas that could be associated with water ice, but then it can be associated with other things as well.
Right.
So there's always doubt, at least in those type of measurements. I mean, what you want is in situ sampling. You want either send a rover there to scrape up some of that material and then analyze it either there or bring it back to Earth that we can analyze directly to see if there is water ice in amongst the sampling.
Now, I always have to point out when we're talking about water ice in these conditions, this is not the ice we'll go outside here in North Dakota and pick up off the ground right now. There are denser and other types of ice, water ice, that are there. And you get into some of these ices and they're like granite. They don't sublimate very well because they're locked into a crystal. And so, this is not ice that you have any experience with here on Earth unless you're in one of the specialized labs that looks at this stuff.
I mean, this stuff is under a temperature of like minus probably 200 degrees Fahrenheit or so on average.
Right.
And it's and if you have no sunlight at all, it has no chance to warm up even in that sunlight and evaporate off. And of course, if there's some lunar regolith covering the ice, it's harder for it to evaporate anyways, right? So it could be several inches below the surface.
So,
yeah.
you know, the reason I mention that is because I hear a lot of people sneering, there's no way ice could, exist in a vacuum and everything. And it's like, it's not sublimating. It's not earth water ice. It's this weird form that you got to get down to really cold temperatures and the right pressure range. So, I recommend looking up something like Ice 7 and look at its properties and then come back to me.
Well, the other thing is what is the source of the ice?
Right.
And people speculate it was brought in by comets. In fact, that leads into a whole discussion. What is the source of water here on Earth? And people have speculated that the water has come from comets.
Right.
And one of the things you look for is the isotopic ratios. So different atoms, you can think of H2O, so you got oxygen, and look at the different isotopic forms of oxygen, and how does that match what you see in the ices of different comets. Sometimes we've heard news, and we've even reported on this podcast, that the isotopic ratios didn't match, so it was hard to think of ice coming from comets. But then not all comets are the same.
Right.
And so we've discovered comets where there has been a match now. And so then people said, okay, then the source of ice can be from comets. Right. Well, on the moon, and if you have a comet that bombards the polar regions of the moon, and there could be many of them. I mean, the moon's been around for as long as the Earth's been around, for 4.5 billion with a B years. Right. There's lots of times for comets then to have intercepted or hit the surface of the moon, especially early on in the period of heavy bombardment or the early days when there's presumably more of this debris flying around the solar system, that it could have brought at some point water ice to the surface of the moon and been buried a little bit underneath the soil. And there it is today, forever, if you like, in that nice refrigerator in the dark.
And it probably would be a different setup than for Earth, because Earth, due to its thick atmosphere, relatively speaking, you also have the issue that water could have been delivered to the Earth via hydrous minerals in more rocky bodies like meteors and so forth. So, yeah, this is a huge, wide open area for study and speculation. So
now we should be safe to say that it wasn't there when the moon first formed.
Absolutely not.
If you think that the moon formed from the coalescence of debris caused by the impact of a Martian-sized object that hit the Earth, and some of that material was driven up into orbit essentially around the Earth, and then that came together due to gravity and ultimately formed the moon as we know it today, there's no way the water would have survived that.
Right.
So it had to be delivered after that era.
Right. And that's one of the things about Earth, too. Again, we're back to, at some point, the gravitational potential of all the mass that makes up Earth coming together, it would have heated enough that it should have made the Earth molten.
Right. So we can speculate
So-
about this, but what you really want to do, you get boots on the ground if you can.
Absolutely.
And so that's why the southern pole region of the moon is the primary target for the Artemis 3 mission.
Yeah. Now,
And also for China, too.
right.
I mean, there are other countries that are looking
India
at this
is
area.
looking there.
Yeah, with the unmanned robots
Mm-hmm.
to go there and sample the soil and so on. And so this is going to be one of those areas where kind of everyone wants to get to or would like to get to if they can.
Right. Plant their flag.
Yeah, so that's where Artemis 3 is going to go in that region. Now, the exact spot, I don't think they have picked it.
I don't think
But
so.
in order to get there, you have to have a way of getting from lunar orbit, which we can do with the SLS, with the Orion spacecraft. Right? We have an engine on board that craft which can fire, go into lunar orbit. But then how do you get from lunar orbit to land on the surface and then back up again later? And that was the job, of course, by the lunar module back in the Apollo project days. But we don't have a lunar module today.
Right.
In fact, you wouldn't want to use the one from back in the 60s, even if you had a perfect copy of it and it worked, 100%. You want something that can hold more people, and you want one that would stay on the surface a lot longer.
I agree. Yeah.
And so 2 companies have been tasked to design a lunar landing for the Artemis project. Number 1 is SpaceX, and number 2 is Blue Origin. Now, the initial plans was, well, I mean, they keep changing. So what am I saying by initial plans? 2026, this year, we were supposed to be on the moon.
Yeah.
Then it's next year, 27, then it's the year after, then the year after that. Now it's probably going to be 2030, and it could go even beyond that. Who knows? Right? It depends on, number 1, political support, which I mean financial support.
Right.
Number 2, it depends on how well the R&D goes and the construction, the engineering. So I might give you all the money you need in the world, but what happens if it takes you're running into a lot of problems and it takes you a lot longer to get the system ready to go? I mean, that's possible. In fact, the lunar module, historically, interesting fact, that was supposed to be ready before it was in the Apollo days, and that's why Apollo 8 went around the moon, is because they didn't have a lunar module they could check out in Earth orbit. You have to delay that for a later mission, and you wanted to do something that wasn't the same old thing. Do we need to go back into Earth orbit and check out the command and service module? No, we already done that in the
Right.
previous Apollo mission. So now they thought we need to do something else. So let's take the chance. Let's go to the moon. So they orbit the moon like 10 times or something and then came back. So that's why they did that, because they didn't have the lunar module, right? They had a fake one inside for the weight, the ballast, essentially, right?
And then with 9, they had the lunar module.
They had the lunar module, tested that in Earth orbit.
Right.
And then in Apollo 10, they did everything, and they approached to within 50,000 feet of the lunar surface and then came back. So they rehearsed all the steps leading up to the landing for Apollo 11.
Yeah, an interesting fact there with Apollo 10 is they were afraid that the astronauts would hit.
No.
I heard they left it without enough fuel to get down and
that's
back.
it, yeah. Just in case they decided, no, we're going to land in Apollo 10.
Right.
They didn't put enough fuel in the lunar module, so there's no way they could have returned safely.
Right.
Yeah, I thought you were going somewhere else. I thought that they were going to do that.
I thought they were worried about the astronauts deciding they wanted to go ahead and land. So, yeah, they didn't fuel it up completely.
That's what I heard. Now it could be a urban
be an
myth or
anecdote,
something.
you know.
Yeah, or it could be. But anyways, that's what I heard also.
Yeah.
So the big push now is because the new lunar module lunar lander is also late,
Yep.
and Artemis 2 will happen hopefully in March, but then we have to wait and wait and wait because Artemis 3 needs a lunar lander, and there isn't any available. And like I said, SpaceX, they were hoping that the Starship would be the lunar lander, and they're still trying to get that, work all the
worked
bugs out,
yeah.
and that's going to be a while yet and before it's human rated. And not only human rated by SpaceX, human rated by NASA.
Right.
So it has to be, reliable.
Something about synchronously lighting off, 21 engines?
Well, there's 60 some engines or something.
Yeah.
How many engines are in the the Starship's like 32 or something like that.
That's what I
Some
was
large
getting
number,
at. Something
yeah.
like that.
But there's redundancy. If a couple of them flame out early, they're still okay. You can make it, right?
But
landing on the surface
Yeah.
of the moon, I don't know. You got to get that right, obviously.
Right.
So there's a lot of testing that's involved here, and you want to make the spacecraft as reliable as possible. Well, as a backup, and in some sense, you could argue that you need a backup just in case the method or the technique, the engineering route that SpaceX is taking, let's say, is not the one in terms of the time schedule. They also selected Blue Origin to build a lander. And Blue Origin has been working on theirs for a while also. And an interesting thing why we're talking about this today is that recently, just the other day, Blue Origin came out and said, you know, for a couple of years now, remember they've been sending people up in suborbital flights?
Right.
So you go up to, I don't know,
I think
a little
it's
more
about
than
100,
50
110,000.
yeah, you like 300 and some thousand feet or something, right?
I didn't know it was
above the
quite that
just
high.
above the Kármán line,
Okay.
and then back so you can claim you're an astronaut. Everybody who was on board, William Shatner, you know, Star
Yeah.
Trek fame, Captain Kirk, he got to experience that, as well as Katy Perry,
Yeah.
and a bunch of other people, right, have done this. Well, Blue Origin announced no more for a while. In fact, they've suspended all of these launches for at least 2 years, they said, because they need to focus on constructing the lunar lander. So I think somebody got after them. They said, look, we awarded you this contract.
We want it done.
We want it done now. We don't want it done 20 years from now. And they might say, well, we don't have enough technical staff because half of them are working on the suborbital flight. Well, then
Stop working on the suborbitals.
Stop, put a pause on the suborbital flights and bring everybody on board the lunar lander.
Yep.
So hopefully we will see, therefore, great sort of progress being done on the Blue Origin side of things, and maybe in time to make the 2030 landing, right, if NASA decides to go with them because they're ready before SpaceX. Who knows?
Yep.
Now, we do have a comment that I wanted to address here in the chat. The comment is from Witness Protection 4233. There's huge solar flares over the last 3 days that might be building up to a coronal mass ejection. That's exactly right.
Yes.
In fact, the NASA itself has people who are tracking the space weather. And I heard a report from them just the other day about the space weather. And they were tracking this system of sunspots, which is on the sun now. They're pretty prominent. And they were a little worried, too, about the fact that you can have a huge ramp up in solar radiation during the time when the Artemis mission is going and on their way to the moon. And once you get outside the Van Allen radiation belts, you're outside the magnetic field of the Earth, you lose a lot of the protection. And there's not a lot of protection on board the Orion space capsule.
There can't be.
Yeah, it can't be because you got to keep it light enough. And the other thing is so to get around this, then you don't go when there's going to be a major solar event.
Right.
You have to wait it out. And that may have canceled or postponed, I should say, the launch until March anyways.
Right.
Because of that. So that's a good point to make.
You know, that's one of the arguments, we've never been to the moon, is the Van Allen radiation belts. But what you got to remember is they're not uniform. There are holes in them. And number two, these rockets are moving fast enough that you're not in the radiation belts for very long.
Yeah, it's just a few hours, my understanding.
Right. Now, the problem is getting to the moon is about 3 days. So if one of these CMEs happens, those astronauts are fried.
It depends how strong they are. There's an issue. I mean, you could do various things. You can imagine that the direction in which the radiation, the charged particles, for example, is coming from.
Right.
So you can turn the spacecraft while you're on your way to the moon such that you put as much mass as possible between you and the sun, the source of where the particles are coming from.
Right.
You can do these kind of things, right?
And they help,
and it helps, but you're only limited, right?
Right.
And that's why, for example, when the Artemis 1 mission happened, they had, fake humans on board with radiation detectors strapped to them so they could monitor what is the radiation exposure during a flight to the moon and back.
Right.
So they've done all these kind of things. And plus we know, of course, back in the Apollo days what it's been like. And so we're monitoring the space environment too. We have, spacecraft that can do that. But you like to find as much detail as possible.
Right.
So that's one of the hazards. It's like, you're laying on top of a rocket and we're going to light this sucker. You don't think that's not a hazard?
Right.
That it doesn't blow up the moment it ignites? Obviously that's a hazard. Another hazard is that the sun could have a massive eruption, and before you get back in the protection of the Earth, you get, bombarded by the radiation.
Right.
That's another hazard. I mean, as an astronaut, you sign off on that stuff, right? You're willing to take the chance for the betterment of, humankind, essentially, in the space program, to do these kind of things. It's risky,
Indeed.
regardless.
It's risky.
Regardless, it's risky.
There's a reason they originally started. The beginning started with Air Force test pilots. These guys knew how to take the risks.
Yes, and then they have to control the vehicle in an unfamiliar environment, and so there's a lot of training that you have to go through because of all that. But you can never make it, 100% risk free.
Right.
Regardless, even in the future, 500 years from now, there's going to be a risk in all of that stuff.
Absolutely.
I mean, there's a risk crossing the road to go get your groceries, right?
What are you talking about?
So there's risk in life,
Right.
Anyways, moving on from the Artemis project, I got some good news for you, Robert.
Okay.
So we have talked about this in the past, where there was an industrial plant that was going to be built very close to the European Southern Observatory in Chile.
Right.
And that plant would then mess up everything. It would cause a huge amount of light pollution. And this is also the site of where they're building the world's largest optical telescope, 39 meters in diameter, the extremely large telescope. And that's a lot of money. You're talking over €1 billion in this case to build such a telescope. And yet here comes some company that's going to put a plant nearby that's going to have, lights on all night long type of thing. I mean, that's not a good thing. So there was a lot of public pressure against this. In fact, and then, even politicians got in it and said, Chile's a large country.
Mm-hmm.
It may not be wide in terms of how it spaces across degrees of longitude, but it certainly is very long in terms of latitude, the way it's situated in South America.
They've got plenty of place to put it.
They have lots of places to go. So officially, the owners of the project have decided they will not build near the telescopes in Chile. They will go somewhere else.
Good for them.
So finally, somebody came to their senses.
Right.
And this is a big industry. You may not think about it, but Chile has hosted telescopes for decades.
Mm-hmm.
And the agreement that I initially heard was that if you put a telescope in Chile, 15% of the observing time is for astronomers from Chile. So if you put your massive 39-meter telescope in Chile, then you're helping the local astronomers. So we can build up our expertise in astronomy by taking advantage of that.
Then there's housing and all the other food and everything
All
else
of
that
it.
needs to be brought to
There's
this.
all kinds of
It's
financial...
it's a boon for the local economy.
It is for sure. There's lots of money that can flow into the region because of this, right? By having these telescopes there and people using them on a regular basis. So in some sense, you're cutting off your foot despite your...
Yeah, your leg?
Yeah. And you don't want to do that, obviously. So thankfully, then, smarter people have, taken over this, and they're going to move the plant somewhere else away from this site. So that's a win for science, for sure. Now, an interesting sort of study that came out recently, it was published online on the 23rd of January, is this detection of a sulfur-bearing molecule that was discovered in space. It was actually discovered in a large interstellar cloud. So those are stellar nurseries, right? Some places where there's a high density or concentration of interstellar gas and dust. And those are places ultimately where new stars form. And along with that, of course, planets, and then maybe, who knows, life on one or more of those planets. And so what was discovered here was this it's highly complex type of molecule, and it was the first time it's been discovered. In fact, we've literally detected well over 200 different types of molecules from interstellar space. Mm-hmm. And anytime you detect a new one, it just really kind of emphasizes the fact that, the raw ingredients, you can think of amino acids or all the different types of complex molecules that need to form that we think are the basic building blocks for life as we know it on Earth, that we find those basic building blocks in space as well.
Right.
And that's a good thing if you're interested in probing whether or not life is fairly common or not. And
The stuff for life is definitely common.
yeah, so you just need the next step, taking that stuff and putting it together in a certain way that you actually form life itself.
Right.
Now, just to kind of cover what's coming up on the next podcast, by the way, please listen live because you're going to have an opportunity to talk to a very special guest where we're going to talk about where does life come from?
Right.
What are the basic building blocks of life? How do I go from something that's not alive to something that is alive? There has to be a very important bridge between those two situations. And what is that bridge?
Right.
And just because we don't know the details of how to construct that bridge today doesn't mean it was never there.
Right.
Or that you need to invoke some kind of magic to allow it to happen. We just haven't worked out all of the science yet.
What I like pointing out to people is that just because we don't know everything that goes involved doesn't mean we know nothing. We know quite a bit about how it came about. We just need to fill in the details.
Now, the name of this molecule, I'm not even going to try to pronounce, Robert.
Let me go back to the other slide.
Yeah.
Because
Are you going to try that? Okay.
it is
try that.
2,5-cyclohexadiene 1-thione. And I recognize the sulfur-bearing carbon chains as a thiene. So, yeah, it's hexa means 6, cyclo means in a circle. So it's similar to toluene or benzene, and except it's got a sulfur sticking off to the side like this picture.
So you get the prize today for pronouncing that. Okay? That's why I'm never a chemist.
Hey, organic chemistry has to have some use, right?
Exactly. So anyways, it's pretty interesting. Then it makes you think about what other types of molecules, very complex things, are out there, and we just haven't been able to detect it yet. And how do you detect it, of course, is you look for the spectral signature of these molecules. So you study these molecules in a laboratory, notice what they emit under the right conditions in terms of energy and their spectrum, and then see if you can match that up to any observations that you might take with a telescope, for example.
Yeah.
And that's the way you find these things.
For an organic compound like this, I can say most of the spectral lines are in deep infrared and microwave wavelengths.
Yeah.
Because they're very low energy, their flexure, their springiness, their all of these types of things. And there's just not a lot of energy involved in that. And there's a lot of them. There's a lot of degrees of freedom, as we say. And so, these things aren't the easiest to tease out of the spectral information in there.
Yeah, I mean, this is all was discovered in the microwave region.
Okay.
That's where they discovered. Now, so that makes a lot of sense. That's where you're going to find these things.
Right.
The problem is, of course, if you want to study in detail of these interstellar medium sites, right, these clouds of gas and dust, wouldn't it be great if we could send a spacecraft there and do in situ observations?
We got to get to going mighty fast to get it in a reasonable time.
And one way to go mighty fast
is to use a nuclear rocket.
is use nuclear rockets. Now, this was actually done way back, I would be like the 60s, where NASA was experimenting with nuclear rockets. And they even had some prototypes. I think they even launched one, too, and tested in orbit around the Earth.
I don't think they launched one. I know they tested one and got an incredible specific impulse out of it.
Yeah, and then the attention went away a little bit. And then anytime you use the word nuclear,
right,
then all of a sudden you have people on the Earth that say, is
thinking
this
it's
safe?
a bomb.
Yeah, should we really be launching this stuff? And so on and so forth. So it got a bad rap. And then when 3 Mile Island happened in the 70s, that was the end of that.
That was the end of that.
That was the end of nuclear energy, too, right?
Yeah.
Everybody thought we'd have nuclear plants all over the place.
Which is unfortunate because,
I mean, the problem is, what do you do with the radioactive waste? Nowadays, I think we could use the waste.
Nowadays, they're working on Generation 4 reactors that can use the waste of these old reactors as fuel.
Yeah. In the old days, you'd bury it in maybe in Arizona if they didn't care or weren't paying attention to what was going on in Congress. And, of course, there was big protests about that. Put it in a deep mine in Arizona and leave it there for 100,000 years or something.
Yep.
And one person, well, not one person, but some people suggested it's easy to get rid of nuclear waste. You put it on a rocket and you send it into the sun. The sun's a big nuclear reactor, they tell me.
Yeah.
And that would be the end of the waste. It would never bother anybody. And it's true. If you can get that waste into the sun, that's a good way of getting rid of it. Forever not bothering anybody.
What's the problem?
The problem is this stuff needs to be launched from the surface of the Earth. And even if you were like maybe one out of only 10,000 rockets blow up on launch, so you're highly reliable, so you could send up, 9,999 rockets statistically, and they'd be fine. It's that last one, the 10,000th rocket that would blow up. You're still going to have radioactive waste potentially being put into the upper atmosphere and spread around a huge area, and then you get the fall down of all that material, poisoning a lot of people. Now, other people suggest, well, wait a minute, hold on. We've sent lots of spacecraft in orbit, especially the ones that head out to the outer planets, with plutonium on board.
Right.
And that plutonium, if that was caught in an explosion of a rocket, that would do the same kind of effect. But we built specialized canisters that we are told, it's never happened, so we don't know for sure, but we are told that if the rocket did blow up, as it was launching and the spacecraft was destroyed, that the plutonium would be inside this, if you call it a black box, and contained, that it would not be spread around, to the environment. We're told that would work. Mm-hmm. But no one has ever,
considering the nuclear waste containers are designed on a similar principle, and I have seen the video of them running a train into one of those, and they needed to repaint it, I'm willing to concede it would probably
be
work.
okay.
It'd probably be okay, but...
So maybe we could do that. Maybe the worst stuff, we'd have to just go pick up our waste in these black boxes, and then...
Yeah.
But that was the ideas that some people had. But even if it worked perfectly, that's really expensive, launching a rocket and launching waste.
And you've got to have enough fuel on there to burn.
You get to the sun, and you're going to do that over and over and over.
Bleed off the angular momentum so that it drops into the sun. Yeah.
And that's why some people suggested, those railgun systems.
Yeah.
Right? So you get it controlled by a magnetic field, really strong magnetic field that accelerate, whatever you want to call it, a lifting body that would send it off into... a trajectory that would intercept the sun eventually.
And
just
again,
fire those.
That would take more energy than you got out of the fuel in the first place.
Yeah, so what's the point, right? But then something like that, we could, you could get 200 Gs and wouldn't matter, right?
Right.
Extreme acceleration because there's no living people on board, right? You're just sending the stuff out into space. But yeah, once it kind of defeats the purpose. But anyways, so that nuclear stuff kind of went away. And then a few years back, people started, NASA started thinking about it. In fact, even Congress started saying it's time for NASA to get back to, if we wanted to be serious of human exploration of the solar system and going to Mars even, that we need to reduce the transit time. And one way to do that is have a much more efficient rocket in some sense that has what we call a higher specific impulse is the technical term.
It's the
so it can go faster, accelerate more.
Right.
And one of the things they looked at, again, is the nuclear rocket. So NASA has been working on that. So this is the latest, greatest kind of thing they've been doing. In this case, the idea is you take hydrogen and flow it through the nuclear reactor core itself and heat up that hydrogen.
Oh, wow.
And that hydrogen then would expand and go out the back end of a nozzle type of device. So what the scientists, the engineers wanted to figure out is how does that hydrogen fluid flow when it interacts with the reactor core?
Okay.
In terms of hydrodynamics, right?
Right.
So the image that you see here is the test stand that was made. It was tested down in Alabama, in Marshall, this past year in 2025. And they did these kind of tests then where they're having just a fluid flow over a device that would have the same shape as a nuclear core itself. So it's nothing nuclear here, but it's getting, the first step in the multiple steps that you need to take to eventually get to a point where we have nuclear reactors.
Got to show proof of concept before you really let it, fly.
Yeah, exactly. So there is money being spent then, obviously, on this type of project. Ultimately, the goal is to have a nuclear reactors that would be running our spacecraft. In fact, you could think of the safety thing. Well, let's turn them on when they get a little bit of ways from Earth.
Right.
And then light them up.
I was about to say, this will probably be launched on a chemical rocket.
Yes.
It'll get probably about halfway to the moon. Then you kick in the nuclear.
Yeah, and get it going. So something's going to happen. I mean, just look at sci-fi, right? And you don't have to go beyond normal physics like Star Trek would have you. But just think of what's going to happen like a 1,000 years from now if we're going to indeed explore the outer solar system. Are we wanting to take 20, 30 years to get to Neptune from here? No.
No.
So we're going to have to do the engineering that allows us to do advanced propulsion to try to get these into these places a lot faster than what we can now. And that means probably using nuclear or some other technology.
And to me, for an interstellar probe, you're going to use 3 technologies because you're probably going to use chemical rockets to launch it. I would kick in the nuclear to get it going pretty fast, and then throw out a solar sail for both electrical energy for electrical systems, as well as giving it a continual low power thrust, but a continual thrust.
Yeah, so ion propulsion is not going to work.
No.
That's the ejection of charged particles out the back of the
Sooner
rocket.
you run out of fuel.
Because you have very, very low very, very low acceleration, I should say.
Right.
So the thrust is really small. Even though you can run it for tens of thousands of hours
Right.
and build up gradually your speed, it's still not going to work. It's not enough. We got to do better than that. And that's what we're talking about, nuclear type of propulsion in that case.
Yeah. Get it zipping along with the nuclear, then throw out the solar sail.
And a big push on all of this, of course, is to get to Mars fast.
Yes.
And especially when you think of an emergency, right? Oh, you got to bring back someone to Earth. Well, you're going to have to wait 6 months before we get them there because of the alignment of the planets, or maybe it's a year and a half. If you can increase dramatically your propulsion technology where the trip to Earth only takes a week, that's certainly a lot better, for emergency runs that you may have to make, right? And the other thing
or
is
just non-emergency. We've talked about CMEs earlier.
Yes, that's the other thing.
Outside of magnetic field, the more danger that poses.
Yeah.
So let's give them some thrust.
And Mars doesn't have much of a magnetic field, right? Residual magnetic field left.
Yeah.
But obviously what you can have on Mars is you can have tunnels that go, have habitats below the surface that you can go into to wait out the storm as the radiation passes by.
Right.
And use the Martian soil as a barrier in that case. So there's lots of things you can do. But, obviously if the time of transit time is significantly shorter than what it would be today, that is a major advantages on a lot of things, obviously.
Absolutely.
Now, going to Mars, it's always interesting. We know we have rovers on Mars. You don't hear a lot about, it seems like other stuff kind of takes the headlines and the news that come from all this
stuff. It's been a while
stuff.
since we put one down, so there are a couple that are still working, but...
So this one caught my attention. So this is a research paper that was published recently, and it's based on observations that was taken from the Perseverance, I should say, Martian rover. And this is when it was looking at the crater on Mars, and what it discovered was evidence of ancient beach. So a shoreline, essentially.
Cool.
And there's even waves in the structure of the surface where it looks like it was literally a lake, if you want, or an ocean, and then waves were washing in on the shore. So they detected a shoreline on Mars. Of course, long since gone away, long since dried up. But I thought that was pretty cool that you can actually see it. And Jezero Crater is the location, and there's a nice, beautiful image of that taken from the spacecraft, from the rover. And so you can imagine, you go back far enough in time, then that this crater could have been filled with liquid water, in that sense, filled with water. And obviously the conditions of Mars was a lot different back then than it is today.
Right.
And that's one of the things is what changed Mars. So that's not able to support liquid to support water today. And
that's why I'd want boots on the ground, because there's a lot of things we could test. Is it the lack of plate tectonics? Recharging the atmosphere. Is it the lack of a strong magnetic field? And if so, why did the geodynamo? Because there's evidence that Mars did have a geodynamo. We still don't know how they start, but why did it shut down?
right.
So all the boots on the ground would help with answering some of these questions.
And the other thing to note here is if you went to Mars today and you took a pan of water and put it on its surface,
It boils.
it would explosively evaporate.
Right.
Not just a little bit, but explosively because of the extremely low pressure.
Mm-hmm.
And that certainly is not what existed in the distant past.
Right.
So something happened to Mars. And what is that something? I mean, we see dried up tributaries. We've seen that since the early Viking days, right? In the 70s. So the evidence has been there for a long time that it looks like, liquid of something flowed on the surface. And we
Right.
think it's water, is that liquid. But what changed on Mars? And is it? And when you might say, well, it's Mars. Who really cares? But what happens if that thing that changed could happen to the Earth?
Venus doesn't have a whole lot of water either, but there's evidence that it did.
Then we do care because it can affect us directly.
Absolutely.
So you just never know, what you're going to find in that case.
Mm-hmm.
Interesting when you think about it. But that's one of the reasons why you want to go to Mars, right?
Right.
And then beyond that, of course, you think of space exploration as just, explore the rest of the universe itself. How far in will it ever come, Robert, to the point where we've advanced the technology? Let's start locally, propulsion, where it makes sense now to send out a robot that's going to explore the environment around Proxima Centauri, a little over 4 light years away.
Absolutely. And we should be aiming in that direction.
And we should be
looking to do it.
And we should be still alive when this happens.
We should, but we're probably not.
Yeah, well, that's the way it seems to be going here. We're not going to reach that point. But why stop there?
Absolutely.
And, why not send out probes that can go beyond that? In fact, why not have probes make themselves, the von Neumann type of scenario, where they self-replicate and then go to other areas, and next thing you know, given enough time,
we've explored the whole galaxy.
And given enough time, explore the whole universe in that sense.
Now, I don't believe, I'm the pessimist here, I don't believe we'll ever create the first galactic empire. But it doesn't mean we have to keep humanity here in one basket. We can build ships that carry us out. They just won't be in contact with each other because it takes too long.
Yeah, and even if you do that locally, like you don't keep everybody in the cradle of humanity on the Earth, and you spread them out to other planets in the solar system, and because you never know what happens to the Earth. What happens if something devastating happens and wipes out all life as we know it on the planet?
Right.
Then if that's it, that's where everyone is. That's the end of our species. But if we've had a chance that life take a foothold elsewhere, whether it's Mars or the moons of some of the outer planets or whatever, at least we're still living as a species. We're not totally exterminated.
Right. And to me, that should be one of our goals for certain, Let's get out there. Let's explore. Let's find out what's over the next hill.
There's so much to do.
Absolutely.
And if you want to do some of that, one way of doing that, of course, is to get educated.
Get educated.
Get educated. Get a degree.
Yeah.
If you're sitting back and you're in high school, for example, and you're wondering what to do with your life, we just gave you some options.
Right.
Work on advanced propulsion. Get that engineering degree in aerospace and try to get us to Mars faster.
Faster. Better, stronger, faster.
Look for evidence of life elsewhere. Try to find all of these complex molecules that exist out there in the universe.
You know what? Communicate it as well. We need people that know how to do that, how to write and read and interpret this stuff. So
take AI and try to get it to help you and figure out how you go from something that's not alive to something that's alive. Use all the tools at your disposal and invent new ones.
And invent new tools.
For the next generation.
Absolutely.
And a way to do that is you can come here, for example, to the University of North Dakota, where we have lots of programs, both online and on campus. So if you're interested, especially as a high school student, where you're young and you have a whole life ahead of you, so you have lots of time to develop a very fascinating career, a really starting off point will be coming here to UND for sure.
And if you're on campus, come by and talk to us.
Give us a look up, right?
Right.
Now, our next podcast will occur 1 week from today, so this is on February the 10th. And as I alluded to already,
we're going to have a guest.
We're going to have a guest, and this guest is a biology professor here at UND, and we'll save formal introductions for next week. So we'll have a little bit something else we can talk about, right?
Right.
And we're going to try to concentrate on early life. Like, what do we need for life to exist?
There you go.
Are there special types of complex molecules or arrangement of molecules that, as far as we know, it's conducive for the formation of life itself?
Indeed.
I mean, that when you think about it, if I had a chance to do multiple careers, I always thought that, number one, I'd want to come back as like a cancer researcher, to research in the laboratories of finding different ways of curing at least different forms of cancer. That'd be worth the endeavor.
Absolutely.
And another one would be to work on this problem in biology is how do you get something that's like not alive to something that it's alive. Obviously, it happened at least once
Right.
here on the Earth. And if you figure out those steps in between those two extremes, then you can look and see, does that occur somewhere else in the universe?
Absolutely.
And maybe that'll tell you more information about, are we alone?
Mm-hmm.
Are we
Which
alone?
which is an interesting question, but one some people don't appreciate. But,
Yeah. Now, we always end our podcast with a quote.
okay.
Today I decided to get a quote from Isaac Asimov.
One of my favorites.
So here we go. Here's the quote. Before another century is done, it will be hard for people to imagine a time when humanity was confined to one world. And it will seem to them incredible that there was ever anybody who doubted the value of space and wanted to turn his or her back on the universe.
I remember that quote. Isaac Asimov, for those of you who don't know, one of my favorite authors and scientists. So.
Now, if you like this podcast, please remember to give us a thumbs up. Also, subscribe if you haven't subscribed already, and we will see you next time.
See you next week, folks.
Thank you.
Bye.